Hello everyone. Today I am going to complete this kinetic part. Chemical kinetics where we complete. So tomorrow onwards I will post a different chapter. Okay. So all of you go through this. Now coming to integrated rate law expression. Integrated rate law expression for nth order reaction. See, I already explained about the zeroth order and first order. Okay, and I didn't go through that second and third. So instead of that, let me go through this nth order. If you can put 2 here, you will get a second order reaction. If you can put 3 here, you will get third order reaction, like that. So, integrated rate law expression for nth order reaction. Okay. So, all of you first assume a chemical reaction like this. N moles of A gives rise to products. Okay. Just assume a chemical reaction, N moles of A gives rise to product. Now, at T is equal to 0, let the concentration of a reactant is A moles per liter. And initial product is 0. Now at T equal to T, matlab after certain time period, after few seconds or few minutes or whatever it may be, after T time, let the product concentration is X, then reactant left is A minus X. If X is the product concentration, then reactant left is taken as A minus X. Therefore, rate of reaction is written as dx by dt is equal to k into A minus X power A. Okay. Therefore, rate of reaction that equal to dx by dt equal to k into A minus X power A. So, what I have to take? Dx by dt is equal to k into A minus X power n. Now, similar terms, let me make in similar terms one side. Then dx by A minus X power n is equal to k into dt. Now, let me integrate this equation. Okay. So, let me integrate this part. Okay. Integral dx by A minus X power n is equal to k into integral dt. Okay. Integral dx by A minus X power n is equal to k into integral dt. अब इसको सॉल्व करने से क्या बनेगा 1 by n minus 1 into A minus X power n minus 1. Right, 1 by n minus 1 into A minus X power n minus 1 is equal to kt plus constant, integration constant. Okay, right. Now listen. If t is equal to 0, if t is equal to 0, then x is equal to 0. There is no product at all. T equal to 0, मतलब initial state. If t equal to 0, there is no product. So then x is equal to 0. Therefore, constant is equal to क्या मिलेगा 1 by n minus 1 into A power n minus 1. So put this constant value in this equation. Otherwise, make it as 1 and make this one as 2. Okay. Substitute equation 2 in equation 1. Substitute equation 2 in equation 1. Then 1 by n minus 1 into A minus X power n minus 1 is equal to kt plus 1 by n minus 1 into A power n minus 1. Okay, so let me solve this one. Okay, then kt is equal to 1 by n minus 1 into a minus x power n minus 1 minus 1 by n minus 1 into a power n minus 1. Just n minus 1 make it common. Kt equal to 1 by n minus 1 into 1 by a minus x power n minus 1 minus 1 by a power n minus 1. Okay. Understand? Next. Now, k is equal to क्या? 1 by n minus 1 into t into 1 by a minus x power n minus 1 minus 1 by a power n minus 1. Now that's it. It is the expression for nth order reaction. Right? It is the expression for nth order reaction. अगर आप n प्लेस में 0 लेने से 0th ऑर्डर इक्वेशन आएगा, 1 लेने से फर्स्ट ऑर्डर का मिल जाएगा, 2 लेने से सेकेंड ऑर्डर, 3 लेने से थर्ड ऑर्डर. So like that you can derive all in one expression. Okay? So that's it. It's about integrated rate law expression for nth order reaction. Okay. Now, so let me go through the next topic. Experimental determination of order of the reaction. Roughly go through this. Experimental determination of order of a reaction. Right. So experimental determination of order of a reaction. How you can derive order experimentally? So we can use several methods to determine order of a reaction experimentally. Okay, this my first and important one is a hit and trial method. Okay, so hit and trial method. Hit and trial method. It is also called integrated rate equation method. See, I am going through experimental determination of order of the reaction. So we are going through different methods. That's first method is hit and trial method. See, it is also called as integrated rate equation method. Integrated rate equation method. Okay. Listen. See, can you remember the integrated rate equations for all order reactions? Okay. So I'll give one by one. K equal to x by t. So this is for 0th order reaction. Okay. K equal to 2.303 by t log a by a minus x. So this is for first order reactions. Okay. So like that for second order. Okay. K equal to अभी जो nth order में nth order reaction अभी पढ़ाई की थी ना, वहाँ पे डाल के देख लीजिएगा. You just keep 2 in n place, right? n minus 1 मतलब 1 by t. Okay, 1 by t into x by a into a minus x. Okay, 1 by t into x by a into a minus x. Yes. अरे बाबू, the nth order expression already पढ़ चुके हैं अभी. वो n place में अगर if you take 2, then you will get this expression. K is equal to 1 by t into x by a into a minus x. This is for integrated rate expression for second order reaction. Similarly, third order के लिए क्या करेंगे? In the same way, K is equal to 1 by 2 into t. Okay, 1 by 2 into t. Again, x into 2a minus x by x into 2a minus x by और क्या मिलेगा? a square into a minus x whole square. A square into a minus x whole square. So this is for third order reaction. So these are all integrated rate expression for different order reactions. Now क्या करना है? whatever data given to you, you just verify the data in these expressions, where the K value remains constant at all concentrations. That indicates the order of the reaction. For suppose, आपको एक डेटा मिल गया, तो you have to verify first zeroth order. कैसे verify करना है? Different concentrations, K value, different concentration, different initial concentration at different time intervals, K value you have to calculate. If all are coincides, मतलब the K value remains constant, it is zeroth order. अगर अलग-अलग calculation आ रहा है, मतलब different initial concentrations at different time periods, the K value is also different, then it is not zeroth order. Then you have to verify first order, then you have to verify second. Like that, where you are getting K remains constant, where you are getting K constant, that indicates the order of reaction. But this is not a good method because it is a time taking process. Hit and trial method, it is a time taking process. Okay. So इससे अच्छा methods थे, इनसे अच्छा methods थे हम बताएं. So this is the first and important one, hit and try method. Okay. The second and important is, listen carefully. So second and important method is Wadhoff's differential method. Wadhoff's differential method. Okay, so listen carefully. What is this Wadhoff differential method? Okay. You just assume a reaction at two initial concentrations. Okay. Assume a chemical reaction. Assume a chemical reaction at two different initial concentrations. Assume a chemical reaction at two different initial concentrations, C1 and C2. Okay. If R1 is a rate of reaction, if R1 is rate of reaction at concentration C1, R2 is a rate of reaction at concentration C2. Right? If R1 is the rate of reaction at concentration C1, R2 is the rate of reaction at concentration C2. Then R1 is equal to K into C1 power n. R2 is equal to K into C2 power n. Okay. So as per the rate law expression, R1 is equal to K into C1 power n, R2 is equal to K into C2 power n. K is same ना, दोनों same reaction का ले रहे हैं तो K remains constant. Now take the ratio. तो R1 by R2 is equal to C1 by C2 whole power n. R1 by R2 is equal to C1 by C2 whole power n. Now log R1 by R2 is equal to क्या? Log R1 by R2 is equal to a power becomes n log ना, n log C1 by C2. N log C1 by C2. Okay. Then n is equal to, मतलब order of the reaction is equal to क्या? Log R1 minus log R2 by log C1 minus log C2. Okay. Log R1 minus log R2 by log C1 minus log C2. Like that you can find the order of the reaction. This is called Wadhoff's differential method. Is that clear enough? Next, another method is a half-life method. See, this is a very important and very good method, that is half-life method. And let me go through the third one. Half-life method. Okay. See, you can go through this half-life method. You can find the order of reaction. कैसे? See, please remember, T half is inversely proportional to 1 by A power n minus 1. You can verify all the order reactions here. T half is proportional to, inversely proportional to a power n minus 1, where n is order. n 0 होगा तो T half is directly proportional to a, 0 इतना, right? n 1 होने से T half is independent of initial concentration. So like that, all the order reactions are coincides with this equation. T half is proportional to 1 by a power n minus 1, where n is order of reaction. Now let me assume two different half-lives at two initial concentrations. Okay. Then T dash half is proportional to 1 by a dash power n minus 1. T double dash half is proportional to 1 by a2, or better to say a 1 लिख सकता है, a2 भी लिख सकता है, आपका मन से, power n minus 1. Then T dash half by T double dash half is equal to a2 by a1 whole power n minus 1. Okay. So like that you can predict the order of reaction. T dash half by T double dash half is equal to a2 by a1 whole power n minus 1, where n indicates the order of the reaction. So this is half-life method. Okay. Next, another method is there, that is graphical method. See, another and important method is what we call the graphical method. Okay. Listen carefully. Graphical method. See, in this method you just verify the order of reaction according to the graphs. Okay. For example, dx by dt, order of the reaction, dx by dt means, rate of the reaction is a minus x. If the graph is like this, rate is independent of concentration at that instant of time, then it is considered to be what? What is it? Zeroth order reaction. So this is considered to be zeroth order reaction. Okay. Next, dx by dt versus a minus x. If the graph is like this, of dx by dt versus a minus x graph is like this, then it is considered to be first order reaction. Okay, that is the first order reaction. Next, again, dx by dt a minus x whole square is like this. It indicates a second order reaction. Next, dx by dt versus a minus x whole cube. This is the third order reaction. Okay. So like that, rate versus concentration at that instant of time, that indicates a different order. See, zeroth order, first order, second order and third order reaction. See, नीचे नहीं दिख रहा है यहाँ पे, I am writing here. This is for second order reaction. This is for third order reaction. Okay. Right. So this line, I think it may not visible, I think. A minus x whole cube. Right. A minus x whole cube. So that's it. So this is a graphical method. You can go through half-life graphs also. Not only this one, you can go for half-life graphs. Okay. So graphical method में you can predict the order as per half-life and initial concentration graphs also. Half-life versus initial concentration. Okay, first T half versus A is like this. This is zeroth order reaction. T half versus A graph is like this. It is zeroth order. Next, T half versus A is like this. It is independent of initial concentration. It is the first order reaction. Right. Now, second order and third order के लिए एक ही इक्वेशन, एक ही ग्राफ लिख रहा हूँ बाबू. मैं सेकंड ऑर्डर थर्ड ऑर्डर के लिए एक ही ग्राफ लिख रहा हूँ. क्या? T half 1 by a power n, 1 minus n. अब a power 1 minus n लिया, right? A power 1 minus n. So this is for what you call second and as well as third. Okay. See, second order मतलब n2 लेने से क्या है? n2 लेने से second order के लिए, n3 लेने से third order के लिए, you will get the respective graphs. Okay. So that's it. It's about a graphical method. The last and final method is Oswald's isolation method. Say experimental determination of order, in which the last method is Oswald's isolation method. Oswald's isolation method. Sir, what is this method? How you can predict order in this Oswald's isolation method? Now you have to assume a chemical reaction like this. You just assume a reaction A plus B plus C gives rise to product. Okay. A plus B plus C gives rise to product. Okay. Now, in step 1, listen carefully, in step 1, okay, if concentration of B and concentration of C taken in excess, if concentration of B and concentration of C are taken in excess, and कोई भी reactant if it is taken in excess, rate is independent of that reactant. If a concentration of particular reactant is taken in excess, rate is independent of that concentration term. So by taking B and C excess, तो क्या होगा? Rate depends only on A. So order with respect to A can be calculated. Okay. Therefore, rate is independent of B and C. Therefore, order with respect to A can be calculated. Order with respect to A can be calculated. Okay. Next, step 2. अभी क्या करेंगे ना? If concentration of B, wait a minute. अभी if concentration of A and concentration of C are taken in excess, तब क्या होगा? Then rate is independent. Then rate is independent of concentration of A and C. Then rate is independent of concentration of A and C. Therefore, order with respect to B can be calculated. समझ गया? So that's why isolation method. Okay. Now step 3. I think you can automatically understand. अभी क्या करना है? Concentration of A and B are taken in excess. A and B are taken in excess. Then rate is independent of concentration of A and B. It only depends on C. Then order with respect to C can be predicted. Like that, first you find partial order, and sum of the partial order gives rise to complete order of the process. So that's it. This is Oswald's isolation method. So these are some experimental methods to determine the order. Now coming to the last and final topic, molecular collision theory. Molecular collision theory. It is also called collision theory of reaction rates, or simply called collision theory. Okay. So let me go through collision theory. Collision theory of reaction rates. Okay. So all of you listen carefully. Collision theory of reaction rates. It is also called molecular collision theory. Okay. Now all of you listen. How you can explain this collision theory of reaction rates or molecular collision theory? One thing you should understand. This theory is applicable for only gaseous reactants. But this theory is useful or applicable for only gaseous reactants. Solid reactants and liquid reactants के लिए we cannot follow this theory. क्योंकि if reactants are assumed to be gases, then only they undergo collisions. Okay, so that's why this is only the drawback of this theory. It is applicable for only gaseous phase reactions. मतलब reactants must be gases. Okay, for a reaction to proceed, the reactant molecules must collide with each other. First point क्या बोल रहा हूँ? What is the first point? It's a simple theory. Just I'll explain it like this. Okay. Say for a reaction to proceed, for a gaseous reaction to proceed, the reactant molecules must collide with each other. Reactant molecules must collide with each other. Okay. So, just by making collisions product formation हो जाएगा क्या? No. ना कोलिजन ओनली कोलिजन्स होने से तो प्रोडक्ट तो फॉर्म नहीं होगा, उसके अलावा कुछ एस्पेक्ट्स भी लेना पड़ेगा. सो रिएक्टेंट मॉलिक्यूल्स मस्ट कोलाइड विद ईच अदर. सो दिस इज द फर्स्ट पॉइंट. सो ड्यूरिंग दिस कोलिजन्स यू शुड कंसीडर टू एस्पेक्ट्स. वन इज एनर्जी, द अदर वन इज ओरिएंटेशन फैक्टर. सो कोलिजन्स आप जब ले रहे हैं प्रोडक्ट फॉर्मेशन के लिए कोलिजन्स का जरूरत है. इसके साथ साथ orientation factor and as well as energy factor are required. Okay, see, to form products, okay, two factors are important. So one is a energy factor. So second one is a orientation factor. First is energy factor and the second one is orientation factor. Okay, let me go through in detail about these two. First one is energy factor. Okay, all of you please remember the energy associated with reactant molecules. The energy associated with reactant molecules under normal conditions. समझ रहे? The energy associated with reactant molecules under normal conditions is called normal molecules or normal energy. But the energy associated with reactant molecules under normal conditions is called normal energy. Such molecules are called normal molecules. Collision between normal molecules never gives rise to product. Collisions between normal molecules never gives products. समझ गया? The energy associated with reactant molecules normally are considered to be normal reactant molecules, and the energy is normal energy, and the collision between them never leads to formation of product. तो क्या होना चाहिए? सुनिए, the reactant molecules must possess certain minimum energy, right? The reactant molecules must possess certain minimum energy to convert it into product. That is called threshold energy. उसको क्या कहेंगे हम? Threshold energy. The reactant molecule must possess certain minimum energy to convert it into product. That is called as threshold energy. That's what we call threshold energy. Okay. So, if you consider a graph, okay, energy versus reaction coordinate. Energy versus reaction coordinate graph. Okay, if this is energy of reactant and this is energy of product. So, energy of product greater than energy of reactant. No doubt it is endothermic reaction. But it is endothermic reaction. Okay. Now the highest point is called threshold energy. The highest point is considered to be threshold energy. Then this is the energy of normal molecule. This is the energy of normal molecule, threshold energy. नाउ इन दोनों का डिफरेंस को हम क्या कहेंगे? एक्टिवेशन एनर्जी ऑफ फॉरवर्ड रिएक्शन, EAF मतलब एक्टिवेशन एनर्जी ऑफ फॉरवर्ड रिएक्शन, एंड दिस इज नॉर्मल एनर्जी ऑफ प्रोडक्ट्स. इन दोनों का डिफरेंस थ्रेशोल्ड एनर्जी एंड नॉर्मल एनर्जी ऑफ प्रोडक्ट. This is activation energy of backward reaction, and remaining is delta H, मतलब enthalpy of the reaction. Now this is the graph for what you call endothermic reactions. So sir exothermic के लिए कैसे लिख सकता है? बाबू exothermic के लिए मैं यहाँ पे लिख रहा हूँ. Again energy versus reaction coordinate. Energy versus reaction coordinate. Okay, if you take a exothermic reaction, it will be like this. Okay, for exothermic reaction, the graph will be like this. This is energy of reactant and this is energy of product. Energy of product is less than energy of reactant. Okay, now this is the maximum point is called the threshold energy, right? Maximum point is the threshold energy. Now, the difference between normal energy and threshold energy is activation energy of forward reaction, and this one is the activation energy of backward reaction, and remaining part is delta H. So दोनों में common equation कैसे लिख सकते हैं आप? Common equation activation energy of forward is equal to activation energy of backward plus delta H. ये delta H साइन के साथ लेना पड़ेगा. एंडोथर्मिक है तो पॉजिटिव वैल्यू, एक्सोथर्मिक है तो नेगेटिव वैल्यू. सो दिस इज द एनर्जी कंसीडरेशन. अभी देखो, दिस इज एनर्जी ऑफ नॉर्मल रिएक्टेंट मॉलिक्यूल. कोलिजन्स की वजह से इट्स एनर्जी इंक्रीजेस, रीचेस टू मैक्सिमम एंड देन कन्वर्टेड इनटू प्रोडक्ट. सो रिएक्टेंट मॉलिक्यूल्स एक दूसरे के साथ कनेक्ट कोलाइड होके उसके एनर्जी बढ़ते रहेगा. तो वंस दे गॉट सर्टेन मिनिमम एनर्जी, दैट्स कॉल्ड थ्रेशोल्ड एनर्जी, then they automatically converted into product. Okay, now the energy difference between threshold energy and normal energy of reactant molecules is called activation energy. Okay, so what is activation energy? Or if you listen carefully, activation energy A is equal to threshold energy minus energy of normal reactant molecules. समझ गया? So threshold energy minus normal energy of normal molecules gives activation energy. So activation energy is equal to क्या? Threshold energy minus energy of normal reactant molecules. Now what you understand? Molecules which possesses activation energy undergo collisions and forms products. Such collisions are called active collisions. Such molecules are called activated molecules. फिर से बता रहा हूँ, molecules which possesses activation energy are called activated molecules. The collisions between them leads to formation of products. But actually, these collisions are very less. These collisions are represented by a factor exponential power minus EA by RT. So this is called as a Boltzmann factor. It indicates the number of fruitful collisions. This exponential power minus EA by RT is the Boltzmann factor. It indicates the fraction of active molecules which are always less. Fraction of active molecules when compared to the total collisions. Fraction of active molecules are represented with this factor. We call it as a Boltzmann factor. Okay, so that's why now we are writing K equal to A into exponential power minus EA by RT, Arrhenius equation, where Arrhenius factor, A is Arrhenius factor, K is rate constant, EA is activation energy, R is universal gas constant, and T is absolute temperature. And one more important point, A is the product of Z into P. But A is considered as the product of Z into P. Therefore, K equal to P into Z exponential power minus EA by RT. This is the Arrhenius equation, where Z is called collision frequency. But where Z is considered to be collision frequency. and P is orientation factor. P is considered to be orientation factor. इसके बारे में बताएंगे. First collision frequency क्या होता है? The number of active collisions per unit volume of reactant is considered to be per unit volume, per unit time also. The number of active collisions per unit volume of reactants per unit time is considered to be collision frequency. Okay, so Z indicate collision frequency, and P is orientation factor. Not only energy, orientation of collision also very important. Okay, see, not only energy, orientation of collision is also leads to the formation of product. For example, you just imagine like this. अरे बाबू, this is a dimolecular reactant. Dimo मतलब it's a मतलब diatomic molecule. Diatomic molecule. It is a reactant. Now, if the collision orientation is like this, बाबू ऐसा collide हो रहा है vertically. If they are collided vertically like this, then it is called as, we are assuming like this, it is a proper collision. Okay, this is proper collision, it leads to the formation of product. Sir, improper कैसे होगा? अगर if the reactant molecule is assumed to be collided like this, then this is improper collision. So this is proper collision, this is improper collision. Okay, or non-effective collisions. These improper collisions never give product. This kind never give product, this kind will give product. इसीलिए product formation के लिए two factors बोले थे, orientation factor and energy factor. Is that clear? So this is a collision theory of reaction rate or molecular collision theory. Say this is not applicable for what? Liquids and solids, only for gases. Sir, what about the remaining? अरे बाबू, उन लोगों के लिए एक्टिवेटेड कॉम्प्लेक्स थ्योरी एक थ्योरी है. सो दैट इज द बियॉन्ड लिमिट एक्चुअली, बट आपको सिंपली हम समझाएंगे. ठीक है, एक्टिवेटेड कॉम्प्लेक्स थ्योरी लिक्विड्स एंड सॉलिड्स में वही थ्योरी एप्लीकेबल है. मतलब रिएक्टेंट्स फर्स्ट कन्वर्टेड टू एक्टिवेटेड कॉम्प्लेक्सेस, and these activated complexes further converted into products. Okay, so like that another theory is there, that is activated complex theory. Understand? So it is applicable for biomolecular reactions which are complexive and involved by liquids and solids. In all these cases we use this theory. Okay, so we completed kinetics, chemical kinetics 100% successfully. Okay, so I'll explain another topic, another new topic from tomorrow onwards. Okay, if you like these videos, kindly share these videos, subscribe these videos, and kindly like and comment also. Thank you very much. Allah.